Hi, Quick Docker is a short video on the key concepts behind Docker, along with an example on test case automation with Docker. This is the agenda for the session. So we'll start with what is Docker. Docker is a powerful technology that lets you run stateless tasks along with its dependencies, that is a very minimal operating system, as a lightweight process called a Docker container. Think about your first computer. Whenever you wanted to buy a computer, you would have always thought about it in terms of the RAM, the storage capacity, and the user experience, or the operating system like a Mac versus a Linux or a Windows. Now, what if you want to have two different user experiences on the same computer? You have something called as a hypervisor or a virtual box, which acts as a mediator between the operating system as well as the hardware, which is the host operating system, and provides two different kinds of user experiences in this example on the right side of the slide. So this is virtualization, and if I have to quote a real world example, it will be the example with the hotels on which we go and stay. The hardware of the hotels are the rooms and its amenities, and the experiences are defined by the hotel staff. Let's say, for example, the same hotel chain offering two different brand experiences, one a premium brand and the other one as a budget brand. I'll not go over the brand experiences in detail here, but it is available in the slide for one to look at and infer. So virtualization is basically providing the user experience of an operating system but on the same machine by hosting a hypervisor. Now, what is containerization? Let's say that different users like Jane, Bob, Ram and Rajan, as defined here, have different kinds of user expectations from the same hotel room. And let's say that if the hotelier allows them to form their own plans and define their own stays, right? So, for example, when Jane says that daily room service is mandatory along with the gymnasium, that becomes her plan. And when she comes to stay, that's what she gets. So Docker works on something similar. The software that is essential for running or documented, or they are modularized as a Docker image. So Docker containers can have any number of softwares in it, and a Docker container is basically the runtime invocation of the plan, which is the image. Okay, time for some action. Now I am asking you to go and search Google for the term called Docker. That will be the test case using which we will be defining or discussing architecture of Docker. Now, the first thing that you will need to do what I have said is a host machine with an operating system, and you need an authentication mechanism to log into the host. Then you need a browser, and once you have the browser, you launch it and then you go to google.com, type Docker and then hit a search. If I have to do some kind of an automation to simulate this user activity, what all you will need? You will need an operating system, you will need an authentication mechanism to log in, then you will need a browser, and once you have the browser, you need some kind of a browser automation framework like Selenium or something, and then you might need a script using which you can invoke the Selenium and perform a Google search. So this is our test case that we are going to execute with the Docker framework in the coming slides. Starting with the architecture. Docker works based on a client-server architecture. A Docker daemon process acts as a server servicing requests from a Docker client. A Docker image is a unit of software that is assembled as a union of an existing image with a delta. So basically, images are made up of stacked file system layers, each identified by a unique hash, where each new set of changes made during the build process is laid on top of the previous changes. As you see in our example, and that is present inside this particular presentation, we first need a Ubuntu for performing a Google search, and we need a browser which is Firefox, and we need an authentication mechanism which is provided by OpenSSH, and we need a scripting framework which is Python, which can be used to invoke Selenium browser automation framework. So what is a Docker Hub or a registry? The Docker Hub or the registry is a place where we place the generated images. It is kind of a repository that is provided by Docker and operated by Docker. And there you can also host your own private registries also. See, the Docker server acts on the Docker file, and it can be used to build a Docker image. And once the image is built, you can run it with the Docker client using the run command. So the build and run are the two commands that are used to build an image as well as run the image as a Docker client. We have this Google Search Unit Test Case project which is available and hosted in GitHub. I'm going to the GitHub in my Firefox. So this lists the set of files that you will need for running this at your convenience at a later point of time. We are going to go over the contents of these files in a live demo exercise, starting with the Docker. So I have a virtual box on which I have Linux. Docker requires a 64-bit Linux installation, or you need a Docker virtual machine or Docker machine which can be downloaded from the Docker website. So what does the Docker file contains? As we saw in our demo presentation, we are requesting Ubuntu from the Docker Hub. The second line is the maintainer, which is Lakshmi Raju, which is myself. Environment tells what kind of environment variables that needs to be sent to the image. Then we are requesting the Docker to run certain apt get commands, which is basically to retrieve software that are required for the image. As I said, every line in this particular Docker file will be executed at the time of building a Docker image by the Docker daemon process to produce one image per step. So every line is a step, and each step produces an image, and this image is cached and stored locally when it try to do a build. So this file is mostly self-explanatory. Then to build Docker, we have something called as build.sh. Here I have tried to do a build without any no cache flag. If you give a no cache flag, Docker will not use the cache and it will try to build everything from the scratch. In this particular example, I have tried to build it from the cache itself. So when I execute buildme.sh, so Docker says that first step from Ubuntu latest, it has found this image which is already available cached. Then maintainer is Lakshmi Raju. So step 0 is getting Ubuntu, and step 2 is adding a tag on who maintains this image. So it tells that I'm using this from the cache. At every stage it tells that using from cache. If I try to build with no cache, then the entire image for Ubuntu, the latest, will be downloaded from Docker Hub, and then it will, on that image, Docker will try to do an update first, and then it will install the CA certificates, it will install Firefox, then OpenSSH server, then Python. Step 3, my image is composed. Then Docker will install Selenium. Step 4, my image is ready. So that's how Docker iteratively builds, and each image is identified by a unique hash. Now if I try to find out the images that are present in my machine, these are the stable images that I have, and apt docker test is the name of the Docker image that I have in my local repository. This can be published to the Docker Hub which is out of scope of this particular session or this video. So that's how I have built it. Now, how I can execute the Docker? I have a runme.sh file which can be used to run the Docker file or the Docker image. So the image name has been provided as Docker N10, but that's not my image that I have built. So I look to Docker images. I find that apt docker test as the name of my image. So I come to runme.sh, I change the name. So I am passing the video camera as a feed. This is an optional parameter I have included to demonstrate that it is possible. Then I provide port 2223 as the mapped SSH daemon port on this local machine to be used for the SSH daemon of the Docker container to connect and provide the SSH service. And I am sharing the sandbox tutorial folder. -v is primarily used for sharing any folder from the file system to the Docker container, and this will be mapped to home tester tutorial folder inside the Docker container. Then I am adding it, I am sharing my video device, which is the camera, and I am providing the host name as the container name. Then I invoke Docker, run these parameters, and then I am passing the image name. So let's see what happens when I do a run. So this tells me that my container already exists. So what I need to do is docker rm my container. So what's going to happen? So Docker is going to run the container, and as part of the test case execution process, it launches the Google browser, it searches for Docker, and it sleeps for some time, and then finally it prints that successful validation of Google search using Selenium in Firefox. We have reached the end of this presentation. You may want to check out this project available in GitHub as a Docker project, and you may also want to try without Firefox browser and see if you can test it with the Chrome browser, or you can eliminate the need for a display server and try XVFB and try it with a virtual frame buffer framework.